Hello, this is Mrs. Dowell, and I would like to do an example for you from section 3.08 of solving for the values of x using quadratic equation, and you know ahead of time that you're going to have complex solutions. This is a very common type of problem that you will see, and you need to be able to know how to deal with this whenever it arises. So to suggest that it has complex solutions would simply mean that the discriminant is negative. Now, if you will recall, the discriminant is this part right here that's under the radical, which in this case, this is just an example that I pulled. The discriminant is positive 36. So there's three things that can happen here. The discriminant can either be positive, negative, or 0. When it is positive, you're going to have two real solutions just like you do right here. When it is negative, you're going to have two complex solutions like we are getting ready to see. And when your discriminant is 0, this goes completely away. Pretend my hand is covering it up. And you see the plus and the minus will no longer be there, and you would only have one solution. So in this case, we're talking about a quadratic equation where the discriminant is negative. So I'm going to use quadratic formula in order to solve for the discriminant. Now the quadratic formula is given as this formula right here. Incidentally, this is on your formula sheet for your end of course exam, so you do not need to memorize this, but you do need to be aware of the fact that whatever is under the radical right here, the b squared minus 4ac, that is called your discriminant. Okay. Each of these values come from the a, the b, and the c, and they're just plugged in here wherever they go. And I would just like to point out to you that there's a plus and a minus right here. That's because of the square root sign. Anytime you take the square root of a number, you're going to have two possible solutions. So I'm going to do this example with you, and we're going to use quadratic formula because quadratic formula is the easiest formula to work with whenever you are dealing with a leading coefficient other than 1. So I'm going to identify each of my values. A is negative 2, B is negative 16, and C is negative 44. Now I can tell you that we know some important things about this parabola right away. One thing we know is that the parabola opens down. We know that because A is negative 2. Another thing we know about this parabola is that the y-intercept is 0, negative 44, because the y-intercept is always 0, c whenever your equation is in standard form, and it is. So I'm going to use the quadratic formula, and I'm just going to start plugging these numbers in. I'm going to start plugging these numbers in and see if I can come up with my two complex solutions. X is equal to minus b. That would be that, since b is already negative, that means minus b would be positive 16. Minus b plus or minus b squared minus 4 times a times c, all over 2 times a, which in this case is -4. Now, I'm going to go real slow here for this discriminant part. Remember, the discriminant is whatever is under the radical, because I am supposed to end up with a negative number. And the reason I know that is because this told me that my solutions are going to be complex. So let's take this carefully, slowly and carefully. -16 times -16 is a positive 256. Be aware, common mistake, if you plug it into your calculator, you want to put parentheses around your -16. Minus, that's this minus, 4 times -2 is -8. 4 times -2 is -8. -8 times -44 gives me a positive 352. Now, a negative times a negative times a negative is going to be negative. So this part right here trips people up very frequently. So what I do is I try to stress to them to consider calculating this part right here first, leaving this negative alone. Calculate what is 4 times -2 times -44. In this case, it turned out to be a positive 352. However, the negative in front of it is going to guarantee that we're going to have a negative number. So 256 minus 352 is -96. So let me see if I can clean this up a little bit. So I've got 16 plus or minus -96, all divided by 4. It appears to me as though this is going to be a simple thing. Maybe not so simple, but it's going to be simple enough for us to break down this radical to try to find a perfect square in there. So I'm going to take 96 and see if I can figure out, are there any perfect squares in there? Well, let's see. 96 divided by 4 is 24. And then 24 divided by 4 is 6. So it looks to me like there's a 16 in here. It looks to me as though 96 is equal to 16 times 6. And I'll just check that on my calculator to make sure I haven't made a mistake. Now we need to clean this up over here. So 16, this is x is equal to 16 plus or minus I rad 96 over 4. And you may be saying, what? Recall that if you have a negative under the square root, you must pluck out your i's. Pluck out your i's. So this negative under the radical right here, that is how we knew we were going to have imaginary solutions. All right, then perhaps you can see that there's a perfect square root here. In other words, I square root of 96 is the same thing as I times the square root of 16 times the square root of 6. Well, the square root of 16 is just 4. So this is going to be 4i times the square root of 6. So if I write this, x is equal to, I'm going to write this as 16 over 4 plus or minus 4i square root of 6 over 4. So you may be asking, why are you splitting that up? Because that denominator goes underneath both of the parts of the numerator. So then when I simplify this, this becomes x is equal to 4 plus or minus, this cancels out, and I have I square root of 6. Okay, hope that wasn't too bad. The answer turned out pretty nice, actually. There are two complex solutions, and we can take a look at our discriminant chart and notice what we ended up with under here was a negative 96. When your discriminant is negative, you get two complex solutions. If your discriminant is positive, as it was here, you get two real solutions. And if your discriminant is 0, you will get one real solution at the vertex. Okay, I hope this has been helpful to you.